Hello, everyone. My name is Shantonu Bhadury. I am the Design Engineering Director in Silicon Labs. Silicon Labs is a fabulous semiconductor company leading the development of secure wireless technology for a more connected world. Silicon Labs has been developing the building blocks for Internet of Things market for over a decade and are considered thought leaders in this space. I have been with Silicon Labs for the last 14 years and have lived through the evolution of IoT, and I'm responsible for creating wireless system on chips that is driving the current IoT products and will define the next generation of IoT applications. I would like to thank you all for joining me today as I talk about the Internet of Things and its impact on sustainability. I'm available to answer any questions you may have throughout the session, and I would love to hear from you. I will also be in the networking room after the session to speak with you about any of the topics that I cover in the next 25 minutes. So, before we go deep into the topic of IoT and sustainability, it is important to understand the term IoT. The Internet of Things, or IoT, is all around us. It refers to the billions of physical devices around the world that are now connected to the Internet, all collecting and sharing data. We have made significant strides in the wireless technology over the last decade, making this explosion of the connected devices possible at an affordable cost. There is a lot of value that can be tapped from the data collected from the devices and making intelligent decisions based on them. All this can be achieved with minimal and no human intervention. Let's talk about some examples of Internet of Things. Any physical object can be transformed into a smart or IoT device. All it needs is a means of communication, either wireless or wired, to communicate information and to act on that information. A simple device like a light bulb can be controlled using a smartphone. Similarly, a smart thermostat can start cooling our home when we leave office. We can see half-hourly electricity consumptions on our phone because of the smart meter that is situated outside our home. Simple electronic shelf label that you see on NTUCs can be used to update prices quickly, create limited period promotions, or even track shopper density in a departmental store, all done remotely and in a synchronized fashion. Next, I would like to talk about some of the basics of IoT, specifically the salient features of the things. As I mentioned earlier, the power of IoT comes from the ability of connecting large network of devices together. There are usually hundreds and thousands of nodes connected together and controlled by a gateway or router, similar to what each home or office or factory already may have. Now, let us understand what it means to be an IoT device. In each of this device or thing, there are three basic elements. One is the interface, next is a compute, and third is a command. So first is an external interface, which directly interacts with the environment and objects. This interface can either be a sensor or a control system or both. With a sensor, the device can detect anything from humidity, temperature, ambient light, voice, pollutants, rain, even antigens, blood sugar level, even fall detector for elderlies, to name a few. With the control system, the device can toggle switches, send calibration data to machines, do complex motor control functions, control display systems, or generate voice functions. So next, there is a compute engine. This can be a microcontroller or processor running software algorithms. There can be also be a dedicated hardware engine to do data processing. The key function of the compute engine is to use the information from the sensor to do profiling, classifications, some filtering if needed, or some data analytics. It can also be used to translate the command that is sent to the device into actions using the control interface. So the last element is a connect, which essentially links the node to other nodes and to the gateway. The connect engine is triggered when the node has any interesting data to send to the gateway for further actions, or the gateway has any control commands to send to the node. The nodes usually don't control each other, but can create a link between the nodes and to the gateway to form a highly connected mesh. This helps a big scale IoT deployment where the gateway doesn't need to be directly connected to all the nodes. Some of you may be wondering, why do we need IoT in this world and where it can be used? So let me briefly touch on some of the uses of the IoT, which I'll talk in more details later on as well. So first important thing is this knowledge is power. Knowing usage trends, patterns can help us change the way we consume or use our resources. For example, I use some monitors in my distribution box to track electricity consumption in our house. So after we bought the new washing machine, I realized that a quick 15-minute cycle was taking up more electricity than an hour cycle, but it was not intuitive if you don't see the data. Second aspect is to enrich our lives. Many people have smart home setup or smart lighting controls or voice assistants like Alexa or all of the world. These devices can be configured to fit our lifestyle. For example, there exists a system that when you turn on Netflix, the lights can dim automatically, the shades close, and the air conditioning is preset to the right temperature. The third aspect is to optimize resources. The IoT enables optimizing of resources, but I will talk more on this in the subsequent sections when I talk about sustainability as well. The next point is to save costs. So predictive maintenance of machinery can save businesses huge sums of money to replace costly machinery and equipment. The last use, which I feel is important to know, is to add predictability and precision. For example, if you see a solar farm that you see on the Tenge Reservoir, during the fitting of the solar panels, it is important to control the torque or the amount of turns in the screws to prevent the fine cracks in the panel, which leads to lower panel life. This is achieved by pre-programming the screwdrivers with the correct energy profile of the motors and then deploying it across all the equipments that is used to deploy such systems. Now, let's focus on sustainability. So the need for sustainability is ingrained in the Uwcsea culture, and rightly so. We want to leave behind a planet that is better than what we started with, which includes our environment, our ecosystem, humanity, and the right mindset to carry the good work forward. Being associated with this community, we are all conscious about the 18 Sustainable Development Goals, which have been created by the UN. For this session, I will pick only 5 of these goals in which IoT is playing a big part. These are Goal 3, which is good health and well-being. Goal 7, which is affordable and clean energy. Goal 9 is industry, innovation, and infrastructure. Goal 12 is responsible consumption and production. Goal 13 is climate action. Now, I will go into some details on the application which are driving these sustainable development goals. First, I would like to touch on is energy. And I would like to focus on mainly on the HVACs, the air conditioning and lighting systems. So customers and communities have placed an increasing emphasis on the sustainable technology for this HVAC and lighting systems. The reason is that 60 to 80% of a building's energy use is attributable to these two systems. So any tool that can help us to reduce the energy consumption in these areas is well worth the investment. IoT and analytics from the data can substantially improve energy efficiency, thereby reducing energy cost and improving sustainability. Even now, the air conditioning equipment has often been regulated by predetermined schedules and configurations, causing wasteful problems like overheating or underheating or cooling across the properties. When our company recently moved to a new office location in Singapore, the first 6 months was spent in understanding what temperature setting we need for the different zones across the office space. And it was a never-ending iterative process. We ended up setting the temperature lower than the comfortable zone because there are some zones where they were warmer than usual, and encourage people to bring in jackets if it gets too cold. So this is a huge amount of wastefulness. In this context, if we had employed IoT sensors which provide real-time granular data combined with on-demand micro-zoned equipment control, we could have tapped into efficiencies in the order of 20 to 30%. And on top of that, if you use the occupancy data, it can also unveil important trends in these systems. that can optimize the equipment schedules. For example, if the air conditioning and lighting systems are set to operate until 8 p.m., but data reveals that tenants don't stay later than 7 p.m., then the facility managers can cut 1 hour of daily energy use and greatly reduce the carbon footprint. So that's on the lighting systems and the air conditioning. Now let's change gears and talk about the usage monitoring. When it comes to this topic of usage monitoring, the wireless utility submeters help deliver consumption data at discrete building areas or even on individual assets, especially the energy intensive one, like the air conditioning heaters, etc. Today's smart meters deliver information to your supplier at frequent intervals, with some models delivering information as frequently as every 15 minutes. So, as I mentioned in Singapore, if you have a smart meter outside your home, you can use your SP Utilities app to access half-hourly consumption and analyze your peak usage data. Having these insights in your fingertips, facility managers or homeowners can swiftly identify and locate bottlenecks for counteractive measures. So, as I mentioned, that I recently invested in installing current monitors on each of the branch of my electrical box. So I was able to change the way of usage by changing the mode of my washer. I changed the luminous intensity and electrical consumption of various lighting systems, air conditioning, energy consumptions, and it helped my monthly energy use by 10%. If we scale this smart meter deployment and educate the users and the facilities managers, we have the ability to gain more control over energy usage by altering the usage habits or pinpointing any issues in the electrical systems as part of a larger sustainability program. Imagine a city like Singapore being able to reduce 10% of electricity consumption. This is equivalent to 2.5 terawatt hour, which can cover two-thirds of all the household electricity consumptions, and that is equivalent to all the HDB electricity consumptions. That's a staggering figure. Next topic I want to talk about is air pollution. Most of the rising global attention to air pollution focuses on impacts that ozone, particulate matter, and other pollutants have on human health. So WHO estimates that the pollution inside and outside the home is responsible for about 7 million premature deaths worldwide. And majority of these deaths associated with outdoor pollution. So this is a leading environmental risk factor affecting urban and rural populations around the world. So if you look at the recent innovations in the low-cost pollution sensors that's enabled new generation of air quality monitoring that provides actionable data at a fraction of the cost of the traditional monitoring systems. So companies now have real-time snapshots of where the air pollution is coming from and traveling to, and who or what is most affected. For example, methane, the primary component of natural gas, is a potent greenhouse gas accounting for 20% of global emissions. The largest source of industrial emissions is the oil and gas industry, which loses 30 billion worth of methane every year from operations. By employing an air quality monitoring system enabled by the low power wide area network, it can provide operators real-time insights into previously undetectable leaks in far-flung remote locations, as well as the ability to remotely control valves to prevent further methane leakage. As sustainability is synonymous to corporate responsibility, this category would also include items related to occupational safety and health. The quality of air inside your building impacts people directly. According to the EPA, poor indoor air quality affects about 30% of the new or the remodeled buildings worldwide, sometimes causing the sick building syndrome. Indoor air quality monitoring can help you achieve better, healthier, more productive environment for employees. So IoT sensors can monitor continuously the presence of common pollutants such as the VOC, the organic compounds, carbon monoxide, and the PM2.5, PM10, the particulate matter. Over time, this data you receive paint an accurate picture of the building's overall air quality and help you determine what actions might need to be taken to improve it. Apart from the pollutants, monitoring of the carbon dioxide can greatly reduce energy consumption. So there is a recommendation from the American Society of Heating, Refrigerating, and Air Conditioning Engineers, ASHRAE. So there is a need of certain ventilation standards. And that standard is based on a full capacity of the building. But since the commercial buildings are rarely filled to capacity, most businesses end up over ventilating their space. So that means you're wasting money, energy on heating and cooling the outdoor air unnecessarily because of the continuous ventilation that you need to provide. So by implementing an on-demand control ventilation system, you can monitor the carbon dioxide level and ventilate only when it's necessary to improve the indoor air quality. As a result, your heating and cooling units use a minimal amount of energy. Recently, our office deployed a series of air filtering systems post COVID-19 era. But I feel that the such systems can be dramatically optimized by adding smart monitoring, occupancy detectors, etc. Now let's talk about farming. Optimizing farming efficiencies opens the door to a sustainable food production system that can cater to global demand while reducing resource usage and environmental footprint. Powered by granular wireless systems, smart farming systems deliver real-time data on soil conditions and various external factors that play into crop growth. An analytics platform then processes this data for demand-based targeted execution of certain farming practices like seeding, irrigation, fertilization, and fumigation. Having enough reliable data at hand, predictive models can even be developed to help identify and prevent conditions unfavorable to crop growth through time-based understanding of how things have been in the past. With IoT technologies, farmers can also monitor the cattle's well-being and get immediate alerts on first signs of illness from anywhere. The equipments like tractors can control planting depth and spacing to optimize growth for different crops or different conditions in the soil. So equipments of all types can be made aware of other machines and their mechanical paths through a field, so avoid damage to crops and assuring more effective conditioning and maintenance of the field over time. So IoT solutions also help farmers to minimize use of pesticides and fertilizers, applying them only where and when they are needed. Reducing the environmental impact of farming and increasing production are two significant benefits of the IoT as it pertains to sustainability. So the potential to remove 1 trillion tons of carbon dioxide from the atmosphere is in our hands. So reduction of dependency on chemicals and focus on regenerative practices will enable recapturing the carbon dioxide in the soil, which we have lost over the years. So next topic is the indoor farming. This is a practice of farming in the greenhouse. However, unlike the traditional greenhouses that rely on sun for the energy, the modern indoor farming uses IoT technology to provide agriculture at a fraction of the space and resources used by conventional outdoor methods. So there's like vertical farming, growing plants vertically in a warehouse setting, using automation to tend to plants, and environmental health. It has shown significant progress. So they use artificial light for LEDs, for lighting optimization, and precise photo period controls, practice that ensure the crop getting the right color spectrum of the light and right amount of light in a day at the right intensity to maximize the crop yields over a short time frame. So indoor farming can also use hydroponic and aeroponic water delivery, eliminating the need for soil. Today, nearly all commercial indoor farming uses precise water, nutrients, and environment management, as well as pest and health monitoring. They are using network sensors and software. So according to recent studies, IoT solutions have the potential to reduce water use by up to 15% and contribute up to 20% savings in food waste through smart agriculture. It's a good setup for the next topic I want to talk about is water. So according to the MIT researchers, more than 50% of the world's population will be living in water-stressed regions by 2050. That's not so far away. It's therefore vital that individuals, companies, and municipalities find ways to reduce the amount of water wasted annually On the average, 85% of the properties waste 35% of the water consumption by means of leaks. Imagine at the municipal level, at the town level, um, the pipe leaks can account to 20 to 30% of total drinking water. In addition, when factoring in the flood mitigation system, 1 or 2 tons of material waste per square meter is produced from demolition due to floods. This also makes mitigating water loss essential to reduce the waste that goes into landfill as a result of the floods. So advances in the IoT sensors and wireless connectivity has dramatically lowered the cost of gathering, storing, and analyzing the data from equipments like valves, pumps, or entire processes like water treatment or irrigation. Sensors can monitor fill levels, control the quality of water, and be used, for example, by installing a leak detection sensor in high-risk areas throughout a building or plant. Facility managers can be alerted on the first sign of a leak, allowing them to take remedial action. Taking a step further, hooking this data to a building management system enables automated responses like shutting off the supply valve or the air conditioning or HVAC equipment. Water is an important metric for sustainability because it's a prime component of everyday usage in most facilities. Pipe leakage is responsible for a significant amount of water loss in industrial and commercial facilities. An IoT solution that detects leakage through dynamic water consumption monitoring could sustainably reduce both consumption and waste. Next, I want to talk about fleets. So, transportation is a big industry in the world, and there is an increasing focus on the environmental impact of different fuel types, particularly the affected diesel engines to have on air quality. And especially with this current energy crisis from the war, it's also more and more independent to be more optimized in our consumption of the fuels. So when you combine with the ongoing drive to reduce the carbon dioxide levels across the board, fleet operators are under more pressure than ever before to make sure their fleet decisions take environmental factors into consideration. So location, fuel consumption, idle time, driver behavior, vehicle health, all play a role in the total emissions produced by your fleet. So IoT sensors powered by low power wide area networks provide critical insights into these metrics to better optimize routes, improve driving behaviors, and ensure timely vehicle maintenance. So for example, real-time location data allows for more accurate and responsive route planning. This reduces the amount of time vehicles spend idling in traffic, producing harmful emissions. Likewise, IoT sensors can be configured to identify and track sudden acceleration or braking, speeding, high-speed turning, frequent stopping, slow driving. So all can result in wasted fuel. So last important topic I want to talk about is something called cold chain. So if you look at roughly 1/3 of the food produced globally is wasted, with much of that loss occurring along the global supply chain. Overall, that translates to 1.6 billion tons of food. That's $1.2 trillion down the chute. Temperature is considered the most important factor affecting the quality of food. Improper temperature control and settings in the food cold chain can accelerate the deterioration of food quality, which can increase the generation of food losses and food waste. Traditionally, personnel along the supply chain will have to manually read and record the temperature of goods to ensure optimal conditions, which is highly prone to errors. This process significantly increases the risk of spoiled products in the event that if the log is recorded incorrectly, not on time, or unchecked altogether. So it's a big issue that can happen. Smart cold chain provides end-to-end visibility of supply chain from production to pallets to cargo retailers. The wireless IoT sensors can track ambient conditions like temperature, humidity, the air quality, light intensity, and other environmental factors in any location across 24/7. When a threshold is reached, alerts are triggered in real time to prompt immediate mitigation and avoid any compromise in the product's integrity. In conclusion, Technology has been one of the reasons for the environmental sustainability issues in the past. However, we are seeing that it is more of an ally right now, to build a greener planet. The proliferation and the push for advanced IoT sensors and connectivity solutions is enabling consumers like us, businesses, and governments to drive energy efficient practices, optimize the use of resources, and enable process that can be help reduce, reuse, and recycle. Thank you for joining me today. I have provided a number of detailed additional resources in links below this video, should you wish to explore this topic in more detail. Now I'll be joining the networking room to continue our discussion. I would love to see some of you there. Thank you again for your time and for taking an interest in Internet of Things and its impact on sustainability.